So Stegman back in 1981, again this is for identifying lactate turn point, surrogate measure of maximal lactate steady state, proposed a test called the individual anaerobic threshold. And they defined it as this. IAT is defined as the metabolic rate where elimination of blood lactate during exercise is both maximal and equal to the rate of diffusion of lactate into the blood. Now, that should be ringing a bell with you, I hope. Look. This is the data from Brooks. This is the schematic of what's actually going on biologically. Blood lactate concentration, triangles. Rate of appearance, rate of disappearance. The notion is that at the lactate turn point, that you've got an equilibrium between the amount of lactate appearing and the amount disappearing. IAT is defined as the metabolic rate where the elimination of blood lactate during exercise is both maximal or equal to the rate of diffusion of lactate into the blood. Just different terminology. Rate of diffusion of lactate into the blood, appearance, elimination, disappearance. So in other words, it fits our understanding of what the blood lactate concentration is and what this sudden kick, LT2, refers to. They've just called it IAT. However, this is where the test looks different. They then state that the time during recovery when the blood lactate concentration equals the value measured at the end of the highest exercise intensity is assumed to represent a time when the elimination of lactate, disappearance, is both maximal and equal to the rate of diffusion, which we have previously referred to as appearance. So where does recovery come from? Well, this is where the protocol differs. Conventionally, remember we referred to doing, in these surrogate indirect methods, 3 to 4 minute workloads. And we would refer to the notion that once you've got to lactate turn point, you stop the test. This protocol is suggesting, well look, there are problems with doing that visually or using a 4 millimole. And now what you do is 3 to 4 minute workloads, incremental test, but you take it to exhaustion. You take it to VO2 max. But you don't stop. At that point, the test is terminated. Now what you start doing is recording lactate in recovery. And you take lactate concentrations, blood lactate concentrations at minutes 1, 3, 5, 8, and 10. Now, think about what you're seeing. They're using you've got now two opposing responses. You've got a response which is the blood lactate during exercise, where lactate will do that. And now you've got the blood lactate response in recovery, where the lactate will do that. Appearance, disappearance, rate of diffusion of lactate into the blood, elimination, where we're getting disappearance in recovery. In other words, they're trying to come up with a method that allows us to conform to this. So the recovery becomes fundamental. So we need the recovery components according to this method to be able to identify accurately what's going on. And it looks like this. Here we've got, and they've plotted it in time, and I'll explain why it's time in a moment, but the X's refer to the blood lactate concentration during exercise. And you can see that they're taking, these are using 3 minute workloads. Okay, so every 3 minutes you take the blood lactate concentration, the workload has been increased, probably by, this is on a treadmill by 1 kilometre an hour. And you can see, you get that curve, but again, it's pretty hard visually to identify lactate turn points. Now they've pushed it to max. So max, you can see the highest concentration right at the top, where that line, where you've got that horizontal line. Then you've got the second curve, and the second curve are the lactate concentrations measured at 1, 3, 5, 8 and 10 minutes into recovery. So we go back to the way they defined the protocol. That what we're interested in is the balance between the maximal rate, where the rate of elimination of blood lactate during exercise is both maximal and equal to the rate of diffusion of lactate into the blood. So the time during recovery when the blood lactate concentration equals the value measured at the end of the highest exercise intensity is assumed to represent a time when the elimination of lactate is both maximal and equal to the rate of diffusion. So what they've done is they've plotted the curve in recovery, they've drawn a horizontal line through the highest lactate concentration during exercise, so it's horizontal, which goes straight through the recovery curve. At that point, you draw a second line and you feed that back to the exercise curve, and the point where it touches the curve, you drop a plumb line down if you convert the time axis to workload, and that gives you the lactate concentration and the workload, which is what they refer to as IAT, but it's what is in essence lactate turn point. A surrogate indication of the maximal lactate steady state. But can you see that it's really trying to fulfill the definition and our understanding of what's going on in terms of blood lactate concentrations and the idea of appearance and disappearance. It seems to get over the issue of doing visual inspection because we're trying to be much more robust in the identification, and it certainly doesn't rely on a fixed lactate concentration. So it works very, very well. However, there are some inherent problems that we have to consider. First problem is, what happens if you don't take them to the point of exhaustion? You don't get that highest lactate concentration. If you don't get the highest lactate concentration, imagine if it was the point below and you plotted the line across. Now you change the intercept line, it would change that lactate concentration. So it's fundamental that we have to get them to the point of volitional exhaustion. Secondly, what do you do in recovery? Is it an active recovery? Is it a passive recovery? And if it is active, how active is active? Because active recoveries eliminate lactate far quicker than inactive recoveries. Now, the convention from McClellan and people like Stegman is that you in essence just use inactive recovery because you're trying to look for that balance. But it has been rejected in many ways. People are saying, well, you've done an incremental test, which is exercise, you should do some kind of active recovery. That's not being cleared up. The other thing to bear in mind is that will have a significant effect then on the IAT, or your identification of lactate turn point, in terms of it seems to over-predict compared to the gold standard maximal lactate steady state and compared to a visual inspection. So it's not perfect. It's not perfect. There are issues with this protocol as well. We are certainly struggling here to find a method that really ticks all the boxes. It ticks the box, particularly in its rationale, but in terms of the way in which we actually run this, it's perhaps lacking the robustness that we need. But it's certainly got some validity to it.